Welcome viewers, in this video we will see the solved problem based on the Millman's theorem. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Calculate the current I in 4 ohm resistor in the network shown below using the Millman's theorem. So the network is given. There are two voltage sources available, 12 voltage and 20 voltage. The two resistors available, 3 ohm and 5 ohm, and one more resistor, 4 ohm. The question is, you have to find the current flowing through this 4 ohm resistor. It is termed as the terminal AB. So the Millman's theorem is nothing but the n number of current sources or n number of voltage sources are converted into single voltage source and single impedance. That is the main objective of the Millman theorem. N number of voltage source or n number of current source with internal resistance or impedance is converted into single current source or single voltage source with a single impedance. So here we have two voltage sources available. So the step one is we will convert these two voltage sources into single equivalent single voltage source. That is the first step. Similarly, there are two resistors available. Then we need to find the single resistance, equivalent single resistance. So the step 1 will go to the step 1. In the given circuit, the two voltage sources are in parallel between the terminal A and B. One voltage source is connected one end of the terminal AB, another voltage source connected another end of terminal AB, so that it is parallel. So this circuit can be drawn as below. So this is the circuit is redrawn. So this is one voltage source with internal impedance 3 ohm. This is another voltage source with internal impedance 5 ohm. This is the terminal AB. In that we have the resistor R. Now we need to find the current I. Right? So the voltage source available this side is now transferred to that side. Now both the voltage sources are drawn in a same side. So we can convert this voltage source with a series impedance, series resistance. Another voltage source with series impedance can be converted into single voltage source and single resistance. So after converting this circuit become very simplified. We are having only one voltage source, one resistor and one load resistor. These are all connected in series. So we can easily calculate the current. I equal to V divided by R, sum of these two current. So that we are converting the two voltage sources into single voltage source with a resistance. Then how will you calculate this voltage and resistance? That is the second step. We need to find this voltage V and resistor R. See these two voltages are parallel. These two resistor also parallel. So there is a formula is available to calculate the equivalent voltage and equivalent resistance. Now we will see how to calculate. We will see how to calculate the equivalent voltage and resistance. So this parallel combination can be replaced by a single source of voltage V and internal resistance R. Then I will calculate V equal to V1 Y1 plus V2 Y2 divided by Y1 plus Y2. So this is a formula available in the Millman's theorem. This Y is nothing but admittance. That is nothing but 1 divided by R1. Both are reciprocal. Resistance means opposing, admittance means allowing. So Y1 is nothing but 1 divided by R1. So that V1 into 1 divided by R1 plus V2 into 1 divided by R2 divided by 1 divided by R1 plus 1 divided by R2. Now all the values are available. V1, V2, R1, R2. The first voltage source is second voltage source. So that is V1 is 12, V2 is 20, R1 is 3 ohm, R2 is 5 ohm. That is available in the diagram. Similarly, R1 is 3, R2 is 5. Right? So we need to simplify this. 12 divided by 3, 4. 20 divided by 5 also 4. Divided by, while taking LCM, we got 8 divided by 15. Right? So 4 plus 4, 8. 8 divided by 8 divided by 15. So 8 cancel. 1 divided by 15 will come to the numerator. So 15 voltage. So after simplifying, we got a single voltage source of 15 voltage. Right? Now we will calculate the resistance. R equal to Y, that is 1 divided by Y1 plus Y2. I already told these both are reciprocal, resistance and impedance. So that we need to find 1 divided by Y1 plus 1 divided by Y1 plus Y2. Y1 is nothing but 1 divided by R1 plus 1 divided by R2. right? R1 value is 3, R2 value is 5, right? So while taking LCM, it is 8 by 15. While going numerator, it become 15 by 8. That is 1.875 ohm, right? Now we calculated the single voltage source as 15 voltage, single resistance 1.875 ohm. So from this we can easily calculate the current flowing through the 4 ohm resistor. That is by Ohm's law, I equal to V by R. I equal to V by R. V is 15 voltage, what we calculated, divided by R plus 4, right? R value what we calculated 1.875. This 4 is the load resistance, right? This is a question. The current flowing through 4 ohm resistor. So after simplified diagram, we have only one voltage source and only one resistance and one load resistance. These two are connected in series, though it is added together. Both are added together. So 15 divided by 1.875 plus 4. That is 15 divided by 5.875. That is equal to 2.553 amperes. So current flowing through the 4 ohm resistor is 2.553 amperes. So in this problem, we calculated the current flowing through the 4 ohm resistor. It is marked as the terminal AB. In the given circuit, the two voltage sources with the two internal resistance available. So the Millman's theorem means the n number of voltage source or current source is converted into single voltage source or single current source. By using that, these two voltage sources converted into single voltage source with a single impedance. After that, the circuit is simplified. From the simplified circuit, we easily calculated the current flowing through the 4 ohm resistor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.